These videos are for March 28th or March 29th, depending on if you're an A-Day or B-Day student. And we started a new unit that will carry us pretty much through April 13th. That's the week right before Easter. And then after Easter, we will be doing a review for our challenge exam. But this unit, we're looking at exponential and logarithmic functions. And what we started with in class is we looked at these two functions and we took time to talk about what is the same, what is similar about these two functions, what is different. And I'm going to go ahead and make that list. I'm going to try to write here. We also try to talk about key features. So I'm going to write similar. So the first thing we noticed is they both have a similar shape. Here it's really small, and then once it gets, one person said, once it gets past the y-axis, it gets really steep, really quick. And so these functions, these exponential functions, they grow quickly, very quickly. Both of these do. Another thing we noticed is that they both cross the y-axis at 1. So they both have a y-intercept at 0, 1. We were able to talk about this a lot during the warm-up, but students, when we talked about it, it makes sense because if we plug 0 into this function, we have 10 raised to the 0. Well, anything raised to the 0 power is 1. Same thing here, 2 raised to the 0, that's just 1. So it makes sense that every exponential parent function, I would consider these both different types of parent functions for our exponential family of functions. They're going to have a y-intercept at 1 because anything raised to the 0 power is 1. So this is a key piece. This is a key thing. Anything that has star in red, that's going to be a key thing that I'm going to ask for maybe on assessment or things like that. Or that will help us graph it. So that's another thing. We also talked about the domain and range. Can you see that? Nope. No, you can't. I'm going to write the range here. Domain. So let's talk about domain. Domain is telling us, hopefully this isn't a shock, all of the x values that the function can take. All the x values that we can plug into the function and get a value out. Well, we can plug anything in for x, we'll get a value. We could plug in 1 billion, it wouldn't be pretty, but we could, and we would get a big value out. Graphically, what this means is it's going forever in the left-hand direction. It's also going forever in the right-hand direction. Even though it's steep, it's going to continue going up and out at the same time. So our domain stays as negative infinity to infinity. That's a key piece. Now the range, and this will probably actually lead us to another thing, so I'm going to make another bullet point over here. Our range, so if we go from the bottom up, we can see that the whole entire graph, this should be really like flat here. The entire graph is from 0 and above. And actually what's happening with these functions is that as we go to the right, as we go along the function to the right, here, this function continues to increase. So the highest point is going to be infinity. That's our highest point. Right? It continues to go up towards infinity forever. If you want to put arrows here, put arrows here. That's going to be true for both functions. Now what's happening as it goes to the left? As we go to the left, people said, well, it's touching 0 here. Well, not really. If you think about it, if you plug 2 to the negative 5 in for x, let's scoot down for a little bit. By the properties of exponent, we can actually make that exponent positive by putting 2 over 5 in our denominator. And 2 to the 5th, let's see, 2 times 2 times 2 is 4, times 2 is 8, so this would be 1 over 32. So it's really small here. And in fact, any value we plug into as x continues to get smaller, it's going to get really, really, really small. It's going to get really, 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 really close to 0 but never touch. And so because of that quality that it's going to go down, it's going to continue approaching 0 but never touch, our range is 0 to infinity. But we can never make this function equal 0. And so it's a parentheses here. So that's another key thing. Two more key pieces that we need to talk about. One, well, hopefully it's fueling the conversation now. If this function goes down and approaches but never touches 0, if this function goes down and approaches but never touches 0, that's another thing. That's another key piece of our function. And what we say is both functions have horizontal asymptotes at, well, y equals 0, the x-axis. So both functions have a horizontal asymptote at y equals 0. The function will never be negative, but it'll also never be 0. It will never go below 0 unless we, add, subtract, move it around. Then it could be below the line. But our parent functions here will never be below 0. So all of our exponential parent functions, they're going to have a y-intercept at 0, 1, a domain of negative infinity to infinity, a range of 0 to infinity, and a horizontal asymptote at y equals 0. The other thing is, let's talk about end behavior. If it helps you, if x is going forever in the left-hand direction, forever, that is going to be negative infinity. If it goes forever in the right-hand direction, it's going towards positive infinity. So on the left hand, we can say as x approaches negative infinity, as x is going towards negative infinity. That's a fancy way of saying as we continue to follow the function to the left, then what's happening? Well, if we continue going in this direction, what we just talked about up here, this function is getting really, 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 really small, really quick, but it's actually never going to touch 0. It's going to approach 0 but never touch. So what we say is f of x approaches 0 on this left-hand side. It's the same thing here. As we go down towards the left, as we get really, 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 as x goes towards negative infinity, as we continue going to the left, it's going to get small, 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 but never touch 0. So over here we can say as x goes towards negative infinity, f of x goes towards 0. Now what happens as x goes towards infinity, or as we move to the right-hand side, as we move to the right, our function is increasing, 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 increasing. It'll never stop increasing. So our function ends up going towards infinity, and that's the same thing that's happening over here. Our function continues to increase, increase, increase forever towards infinity. So these main things, what's written in red, are in behavior here. The y-intercept, domain, range, and horizontal asymptotes, those are the key pieces of our function. Key pieces. Okay. One thing else I want to point out. We already pointed out, because when we graph these, we're going to need key points. Key points are always critical. Here we said 0, 1. 0, 1 is a key point. 0, 1 is a key point. Well, what if we plug 1 into this function? If we were to plug 1 into this function, then we have 10 raised to the 1 power. 10 raised to the 1 power, by the way, this is at 1, 2. The copier is just fantastic here at McGavick High School. If we plug 1 into the function, we have 10 raised to the 1 power. Well, then that should be 10, which is true. So here at 1, the function's value is 10, which means here at 1, the function's value should be 2, which it is. So for all of our exponential functions, we can kind of get these two main points, those two main points to get the actual curve of our function, our parent function, and then we can actually transform it, which is what we're going to see here in a few minutes. If you need to pause it, ask questions about this, please do so. I'm going to give you one real quick definition. We do have another exponential function. It's called the natural exponential function, and that is the exponential function with a base e. So our natural exponential function looks like this. And yes, e is a number. Just like you think pi is 3.14, yada, yada, yada. If you have a calculator on your phone, probably turn it sideways, you'll see e next to pi probably. And if you hit e, you'll see that is 2.71. So just like when we talk about pi, we know that it's 3.14. For e, we should know that that is an irrational number similar in the same vein as pi, but instead of 3.14, it is 2.71. And so this function comes up a lot in different contexts, and this is an important exponential function that we're going to take a look at throughout this unit. On the next video, we're going to look at how we can graph these, transform them, and the key features after we transform them. So please watch the second video if you weren't here for this class.